I'm very pleased to be here today, speaking to you about a topic that's not only timely, it's also incredibly exciting, which is eclipses. I don't know how many of you were able to see or experience the eclipse in 2017, but if you didn't, that's okay. We have a sequel. We actually have two sequels coming. So tonight, what we'll talk about is a little bit about what to expect in the coming 6 months with two solar eclipses crossing the US. Then we'll talk a little bit about why solar eclipses form and what the geometry is, the alignment between the Earth, Moon, and Sun. And then we'll go into a little bit about the science of what has NASA learned from, or what has humanity learned from previous eclipses, and then what science is NASA doing for this current eclipses. And then finally, there'll be a couple opportunities for you yourself to get involved and to follow all of the exciting NASA eclipse things in the coming year. So without further ado, this is the map. And what I mean by the map is this shows you exactly what's happening with two eclipse paths crossing the United States in October 18th, 2023, just about a month, exactly a month away from today. October 14th, 2023, and then April 8th, 2024 with a total eclipse. And what you see are these two stripes cutting across the country in kind of an X pattern that with the nexus point down here in South Texas. The yellow circles here on the left, the ones that cut in from the Pacific down through the desert Southwest and out over the Gulf of Mexico, that is the path of annularity that will happen in 2023. This is a ring of fire eclipse, which we'll get to in a second. And then in 2024, we are treated in April, 6 months, less than 6 months afterwards, to a total solar eclipse where the moon is completely obscured, or where the sun is completely obscured by the moon. And this will come on shore in Mexico and then cut up through the Southwest and through the Mississippi and Ohio River valleys, the Great Lakes, and then out through New England and Maine. These are two fantastic celestial events to participate in. Even if you can't get to these paths, the entire continental US will see some eclipse, some partial eclipse. So it doesn't matter where you are or how much ability you have to travel, you're going to see something on these two dates. However, I would be remiss if I didn't encourage you to travel to these paths. And a total solar eclipse is one of those natural phenomenon that is absolutely breathtaking. And if you have a chance to go see one and you haven't yet, I would encourage you to do so. It is spectacular. All right, so what is happening for the annular solar eclipse? Well, an annular solar eclipse happens when the moon passes in front of the sun, like this slow animation is showing. However, the moon is a little bit too far away and doesn't quite cover the entire sun. So what you end up seeing is not a fully covered sun, a fully obscured sun, but a ring of fire, or the ring of fire eclipse, as you can see right now. That annulus of sun is how it's named, and the annular eclipse happens with about equal regularity to a total solar eclipse. So whenever there's a total solar eclipse, oftentimes there is an annular solar eclipse a few months afterwards. A few months, excuse me, a few years, 6 months to a year afterwards. So what's going on with this in terms of the geometry? Well, here's another fun little animation to show you a little bit of what is actually lining up here. So we have the sun on the left, the moon in the center, and then a shadow cast by the moon onto the earth. And we have some terms there, the umbra, the penumbra, and the antumbra. Here's an animation of what that shadow looks like if we set everything in motion, and now you can see the moon revolving around the spinning earth. Of course, that wasn't to scale. That was very much zoomed in. And so then when we zoom out to an appropriate scale, everything's very hard to see. So that's why we zoom in on things. But you get a sense of what these different shadows look like. They are big in the sense of the planets, but very small in the sense of the solar system. They are just little tiny pinpoints of light and shadow. So this is the eclipse in October of this year. Then coming up in April 8th, 2024, we're treated to a total solar eclipse. So this is a very similar process, except the alignment is slightly different between the sun, moon, and Earth. So the sun is, again, obscured by the moon, but this time the moon is close enough to cover up the entire sun. So as the moon progresses and marches across the sky, it will eventually entirely engulf this, the sun for a couple of brief moments, up to about 4 minutes, and you'll get to see that solar corona around the outside. The solar corona is the outer layer, the most outer layer of the Earth, sun's atmosphere. It's made up of a fully ionized plasma, which is a superheated gas. So if you take gas and you just pump a bunch of energy into it, you strip apart all of the a lot of the electrons off the atoms, and you end up with this soup of charged particles and magnetic fields, and we call that a plasma. This plasma is what a lot of what we study. But during a total solar eclipse, I'll just advance this for a couple of seconds. Ooh. Right during a total solar eclipse, you can see the solar corona with your own eyes. And this is approximately what it looks like. It's this sort of spidery gossamer thin. This, of course, is an animation, but it's a good approximation for what you'll actually observe when you see an eclipse on the ground. Seeing a solar corona, I have to say, even though I study the thing all the time, seeing it with your own eyes is a special occasion. And I would encourage you to travel, if you can, to the path of totality to see it for yourself. So like before talking about the geometry, this geometry is very similar. We have the sun, Earth, and moon, but this time the moon is close enough to the Earth in order to cast a complete shadow. Again, this is exaggerated for detail, so we can set the thing in motion and see the shadow moving around the Earth. The moon's rotation, as you might have guessed, because the moon changes distance in its rotation from the Earth, it is in a complete circle. It's an ellipse. And so depending on where it is in its phase, sometimes the moon appears closer to the Earth and sometimes it appears farther away. This is what dictates whether you see an annular eclipse or total eclipse. It also dictates whether you get a supermoon or, I don't remember the name for the complement to that, but a moon that's very small in the sky. So if you hear the word supermoon, that's what it is. It means that the moon is physically closer to the Earth and appears bigger in the sky. All right. So we have to talk a little bit about safety. Safety is NASA's #1 priority in all of this. And if you're going to experience a total eclipse, you need to do it safely. There's a chance that you could seriously damage your eyes. And that's the last thing that I want for anybody to experience. I want everybody to see it and enjoy it and really get excited. So the biggest thing to think about is anytime the sun is exposed at all, even 1%, even 0.5%, you need to have eclipse glasses on, like the ones shown up here at the top, the white eclipse glasses, or you need to have some sort of protection. It could be a solar filter or something, some screen, solar rated screen to look through. They make large formats and small formats, but the eclipse glasses are the most common. You can go find eclipse glasses if you don't have them already, maybe from 2017 that you saved for yourself. You can go find them often at your public library, your local public library. There are over 13,000 libraries that are participating in eclipse glasses distribution. Chances are you live near one that will have eclipse glasses. Go and check it out. You will likely be able to get a pair for free. So the way you figure out if you can actually that when you need an eclipse glasses is on this NASA map that we have. We have on the side of it, we have listed percentages. And these percentages indicate how much of the sun is covered. In an annular eclipse, we never get to 100% coverage, which means you always need eclipse glasses on. However, during a total solar eclipse, there is a brief amount of time, 3 or 4 minutes typically, that the sun is completely covered by the moon. And you get to see that solar corona, which you wouldn't be able to see with eclipse glasses. So you have to take your eclipse glasses off, enjoy the solar corona, and then put them back on before the sun uncovers again. This is why it's incredibly special, because this moment where you can observe the eclipse with your naked eye is very fleeting and it's very specific to the location that you are. So I'd encourage you to go to the NASA website, nasa.gov, solarsystem.nasa.gov/eclipses. I'll put the website up again a little bit later, and download the map for yourself to be able to get those timings so you know when to expect totality, when the sun's going to be completely covered. A good rule of thumb, though, is if the sun looks bright, you put glasses on, don't look at it. If the sun is dim and you can comfortably open your eyes and look at it, likely it's a safe time. That is just a rule of thumb. That's not an official sort of a way to determine it, but your eyes are very intuitive. If you have to squint and look really difficultly at a bright light, don't do it. Just don't force yourself. If you can take your glasses off, it's completely dark because you can't see anything in your Eclipse glasses, you can take your glasses off and observe the beautiful corona. Okay, we got the safety messaging out of the way. It can be dangerous, but it's very rare that anybody's actually damaged by looking at an eclipse. So I would encourage you to experience it if you're able to. People, however, have been looking at eclipses for a long time. In fact, just about all of humanity, all of human history, people have been observing eclipses. So back in the early, in ancient times, back in ancient China, there were astrologers that were hired to observe and record eclipses. And these astrologers were employed by the emperor in order to make predictions on when an eclipse will happen, because there were a strong mythology built up that when eclipses happen, there would be power struggles and change. And so, of course, emperors wanted to know when eclipses would happen and had astronomers look at eclipses, record them, and predict them. Similarly, texts in Egypt started talking about eclipses about 2000 BCE, before Common Era, to describe the battle between the daytime Ra, the sun god, and Epep, the serpent. So they're talking about the sun being eaten in the middle of the sky. You can kind of imagine that from the animations you saw. It looks like the sun's getting a bite taken out of it or something. So these texts have actually underpinned a lot of what we understand of some of the first observations of eclipses. Also, there are rock drawings or rock etchings. The one here on the left is from Sweden that looks very much compelling like a solar eclipse, and in fact a solar eclipse passed in the area at about the same time that rock drawing was made in Sweden. Even drawings were made up until the 1800s. And so the image that you see on the right is an image from 1857 from Mexico, and when artists would go and follow the eclipse so that scientists could have a record of what they saw and make measurements afterwards. So drawings of the eclipse were the primary way humanity observed eclipses up until we got cameras relatively recently. What have we learned from all of these observations of eclipses? Well, plenty. We've learned an amazing amount about the sun, Earth, and the interaction between the two. One of the major events one of the major discoveries you may have heard about is Einstein's theory of relativity was proven using a total solar eclipse. So Einstein said that light could be bent by gravity. It's a crazy concept. You know, you have things falling due to gravity. That's what Newton said. But then Einstein came along and revolutionized things by saying that not only physical things could be moved by gravity, but light itself could be moved by gravity. It was very revolutionary, and there was a lot of skepticism out there. So using Einstein's predictions, astronomers went out and observed a total solar eclipse and the starlight behind it. And they were able to observe a shift in the position of stars from near the sun during a solar eclipse. They were actually able to image these and measure it and demonstrate that Einstein's theory was in fact the way the universe behaved. Fantastic. Eclipses from antiquity have been used in order to pinpoint the exact length of the day and how much the day is being slowed by the Earth or by the moon. The moon's gravity tends to slow the rotation of the Earth, and by using eclipses and predictions of eclipses from over the last several hundred or thousands of years, the scientists can model the exact change of how much the Earth is slowing down due to the moon. And then even more recently, in 1868, helium was discovered. The scientists were taking spectra of the corona, so they were dividing the corona out into colors of light and found a bright yellow line that they didn't know what it was, and discovered a new element, and they named it helium after the sun, or the sun god Helios. So those are just some of the major scientific advancements that were made during the eclipse, but more recent discoveries have been made too. So recently in 2021, there was a series of publications that were put out by Shadia Habal and her team that have observed the eclipses over several decades. I think she observed it over a 22-year period, and was understood that the corona, that outer atmosphere of the sun, the one that you can see imaged here in false color on the right, that corona maintains a constant temperature despite how many eruptions there are on the sun. So the sun goes through cycles every 11 years approximately, and where there's more solar flares and sunspots. But she was able to prove by looking at eclipses and making careful observations that the temperature of this outer atmosphere of the sun isn't changed by those eruptions, which means that the corona is heated by other means. It isn't heated by eruptions. And that's one of the more significant events significant discoveries that were made recently during solar eclipses. So the eclipse on the right is shown in a polarization filter, and the different colors indicate different polarizations of light. If you've ever used polarized sunglasses, you've actually used a polarizing filter yourself. So coming up in 2024, as well as 2023, annular eclipses are a little harder for scientists to use because the sun isn't completely blocked. But focusing on 2024, NASA is funding 5 different science missions to make new discoveries about the Earth and Sun. So first and foremost, there are two explorations that are going to use the WB-57 aircraft. This is a converted aircraft from a military aircraft for civilian purposes, and NASA has 2 of them, and they mount a camera on the very nose of the aircraft, and they will fly at about 60,000 feet and take images of the sun. The images that you might see are similar to this little animation that you see here in black and white of the sun. That's animation from 2017's eclipse run with these aircraft. So these 2 teams really are going to take images of the sun in infrared light. And infrared light is, of course, a little bit longer wavelength than visible light, but it often, or most of the infrared light is blocked by the Earth's atmosphere, which is why you need to fly up high in an aircraft, is to get above all the water vapor and be able to look at the sun in these infrared wavelengths. It's a good thing that their atmosphere blocks the infrared radiation, because we would, have a whole lot more skin problems if they didn't. So it's a good thing. It also means that we need to go up high in balloons as well as aircraft to be able to observe this. So speaking of balloons, there are going to be high altitude balloons deployed along the eclipse path, making observations of the atmosphere. So one of the major things that can change during the eclipse is the sun's effect on Earth's atmosphere. How much energy the Earth is receiving from the sun is changed because the sun's blocked out for a very small path along the eclipse path. So it's a natural experiment, and you can act as almost like you could switch off the sun for just a few seconds. This is going to allow us to make a really neat before, during, and after comparisons of what the atmosphere is how the atmosphere is behaving. They're going to do that in a couple of different ways. One, of course, is the high altitude balloons. Another one is going to be a sounding rocket campaign, where they're going to launch suborbital rockets that will just go up into the atmosphere and then come back down. And they will take measurements of the atmosphere at every different layer, density, temperature measurements as it goes up and comes down before, during, and after the eclipse. And then also using remote sensing. And remote sensing are like what you see here on the bottom left, that is the Super Darn Radar Array. So this is a radar array that often studies aurora and other atmospheric effects, high atmospheric effects, but this is going to be put into use to study how the eclipse affects the upper atmosphere, the ionosphere. In addition, they're going to have a citizen science component to all of this with ham radio operators, amateur ham radio operators. So if you are a ham radio operator, I would highly encourage you to get involved with the ham sci community. They have opportunities for you to use your ham radio operators to study the underside of the Earth's ionosphere. It's really fantastic. All right. So for all of these resources, getting involved in Eclipse citizen science, as well as many other, I'll have examples on the next slide, there is an Eclipse website for you to go to. You can take a picture or record this, so I can also put it in the chat. The solarsystem.nasa.gov/eclipses is the website that NASA has for all of your Eclipse needs: location, timing, maps, downloadables, safety information, safety flyers, making sure that you can engage with the Eclipse appropriately. If you have a smartphone and are skilled with scanning QR codes, there's a QR code here that will bring you directly to the website. So it's a quick way, a quick shortcut to bring you to the NASA website for Eclipses. If not, I'll make sure to put out the website for you for anybody who wants to explore further with the NASA website on eclipses. On the website, you can find many different resources. You can find the eclipse map that I showed you earlier in super high resolution. You can make it, it has a ton of detail on it. It's a really gorgeous map that was custom made for the eclipses that uses NASA satellites. You can download it for yourself and even print it off if you'd like. We have safety flyers. So if I gave you that safety briefing and you were a little confused, or you wanted it again, or maybe you just want to be able to tell your friends confidently about how to view the eclipse safety, we have safety flyers in both English and Spanish that are available for you to download and print. We also have a couple of fun things as well. We have posters. Here are two examples of posters that you can go and download. They were custom made for NASA for the eclipses, and I think there's 4 of them right now. So here are 2 of them that you can see, and there are 2 other ones that are not there that for you to discover. Print off if you'd like, or just view them online. So to end up everything and to leave plenty of time for question and answers, because honestly, this is my favorite part, is the question and answer. I want to leave you with our Associate Administrator for Science, Nikki Fox. This is what she wants you to do with the eclipses. She wants you to do 3 things: put on your eclipse gluing glasses, and then marvel at the annular eclipse or the partial eclipse for the total, and then look down and take off your eclipse